Hey everybody, here is 8.2. 8.2 is inverse functions. So the first half of chapter 8 feels a little disparate probably, and then we're going to use all these things as we go on through this chapter. This is the end basically, but it is a longer chapter. So when we talk about inverses, we have to first talk about functions. And the first idea is that a function is defined as a set of ordered pairs. So think about an x value and a y value. Okay, so that for every element x in the domain, there's exactly one y. Okay, for example, if you think about going to the deli, you buy a package of deli meat that has so much meat in it that x is the quantity, and it costs a certain amount y. So if you buy a pound of meat, it costs $4. If you buy 2.5 pounds, it costs $10. If you buy 4 pounds, it costs $16. The idea is not, excuse me, that if I go to the deli and buy a pound of meat, I pay $4, and that if somebody else goes to the deli and buys a pound of meat, they pay $3. That's not okay. So that's when things start to sort of fall apart. Things that are functions don't have that happen. 1 pound costs $4 for everybody. It's the same the whole time. If we create a new function where we use the reverse, so we take the x value and the y value and we interchange them, that's called the inverse of the function. So we relate the price of meat, the $4 down here, to its weight, 1 pound. So if you pay $4, you get a pound. If you pay $10, you get 2.5. If you pay $16, you get 4 pounds. That's how it works. When we write inverse, what we write it as is this is f with a -1 symbol. This is read f inverse. Okay, that's not the -1 is just the way we say inverse. It's just notation. It doesn't really mean flip in this case. When we do this, what happens is what used to be the domain of f, okay, is the same as the range of the inverse. So the domain was the x values. Now they're the y values. The range of f, which used to be the y values, is now the domain, the x values, of the inverse. Okay, we switch them. In order for this to work, there cannot be any ordered pairs that have a different x coordinate and the same y. So like I can't buy 2 pounds of meat for $3 and also 1 pound of meat for $3. That's not okay. As long as we're not doing this, the function is one-to-one. That's what it means. So if we have a function and we graph it, it's one-to-one. We can tell on a graph if there is no horizontal line that intersects the graph in more than one point. This is called the horizontal line test, okay? So if a function is one-to-one, you should be able to draw a line straight across from left to right through any part of the graph, and it can't touch it more than once. So if we draw a horizontal line through this one, it touches twice. So what you see here is a quadratic function like we've been working with. They're not one-to-one because you draw that line through and it touches more than once. In this case, I bought a pound of meat for $2, and somebody else, paid $2 they had to give up meat. Like, it just doesn't work right. That doesn't make sense. This one is just half of that function, right? But it does pass the vertical line test because no matter where I draw my horizontal line test, no matter where I draw my horizontal line, it only crosses once. Okay, you'll see, you know how to do these, check them. If something is one-to-one, okay, and is represented by ordered pairs, then its inverse, the inverse of f of x, is given by the reverse ordered pairs, all right? One of the ways to figure this out is that if I have two functions that are inverses, I can tell that f of g of x equals x, and then g of f of x also equals x, okay? So I can find the composition of that function, and if they both come out in either direction to be x, then it works. Then they're inverses. So we can try this. So for this one, I'm going to start with f of g of x. That means I'm going to put g in here where I see x. So I'm going to do 5 times x minus 4 over 5 plus 4. Well, the 5s are going to cancel. I'm going to get x minus 4 plus 4. These guys cancel. I just get x. All right, so then I'm going to do f of, oops, sorry, not f of. Now over here, I'm going to do the reverse. I'm going to do g of f of x. Okay, so I'm going to put this in here. So I'm going to put 5x plus 4 minus 4 over 5. Okay, these guys cancel. I get 5x over 5. The 5 cancels, I get x. So I have an x here and I have an x here. That means that yes, these two functions are inverses. You can try this one, okay? It should work out. If it does not, you know where to ask your questions. Head to the discussion, my friends, okay? So what this all allows us to do is to write the inverse of a function. There's 4 steps. They're the same every time. Follow them every time, you'll be in business. So we're assuming when we do this that the function is 1-to-1. If it's not, you don't find an inverse. So it's got to start from that assumption, okay? The steps are to rewrite f of x as y. Then you swap out where you see x and you put in y, and where you see y, you put in x, and you solve for y. When you're done, that's the inverse. So you rewrite y as f inverse of x. Let's see what that actually looks like. All right, so first step, I'm going to rewrite f of x as y. So I'm going to get 2x plus 1. The next step is to swap where x and y are with each other. If you miss a step in this process, this is the one. But what I'm going to do is I'm going to put x here, and I'm going to put y there. Now I want to solve for y, okay? So I'm going to move x over there. Oh, sorry, I'm not going to move x over there. I'm going to move 1 over there. Minus 1. So I get x minus 1 equals 2y. I'm going to divide by 2. I get x minus 1 equals 2 over 2 equals y. The last step is just to swap out where I see y for f inverse of x. That's it. It's done. That's the inverse of the function. You try this one. When you get this one done, the inverse of this function should be x minus 6 over 4 equals f inverse of x. Okay. Let's try one slightly more complicated. All right. Looks ugly, still works exactly the same way. So first we're going to rewrite it as y. Y equals the cube root of 5x minus 4. Okay. Then we're going to switch x for y. X equals cube root of 5y minus 4. Now I'm going to solve for x. So I'm still going to do what I did before. I'm going to move the 4 over. So I get x plus 4 equals the cube root of 5y. Well, to undo a cube root, right, I have to cube both sides. I'm not actually going to work out what that cubed is. I'm just going to keep it like that. X plus 4 cubed equals 5y. And then I'm just going to divide by 5. So I get y equals x plus 4, that whole thing cubed, over 5. And then I'm going to swap out f inverse for y. Plus 4 cubed over 5. Done. Not the end of the world. Okay, it should have, this was g of x, not f. Same difference. Okay, you try this one. Works the same idea, right? When you get finished with this one, you should have x cubed minus 1, or sorry, plus 1 equal over 2 equals h inverse of x. If you get stuck, come ask in the chat. Discussion. Boy, I still do that. We're this far in the semester. All right. So the last step in here is, I lost my page. I'm out of order. Whew. Okay. This says give the function defined by m of x equals x squared plus 4 when x is greater than 0 to find an equation defining the inverse of m. So essentially what this is if I graph x squared plus 4, right? And I don't worry about this yet. For x squared plus 4, we know, because we've done this, I get a parabola, right, at 4 units up. So when I include the idea that x has to be greater than 0, what that does is it takes this half of my graph away, and then it assumes that I'm only working on that side, so that this is a one-to-one function. Okay, so then we're going to follow the same steps. I'm going to do y equals x squared plus 4, but I have to keep this domain in mind. And then I'm going to switch out x and y. X equals y squared plus 4. I'm going to move that 4. X minus 4 equals y squared. And I'm going to take the square root of both sides. Square root of x minus 4 equals y. So the thing is, the inverse of x is the square root of x minus 4, okay? But it's not going to be always true, right? It's going to be, and in order to say this, I now, because my x and y values are switched, what I have to say, it's when y is greater than or equal to 0, okay? So this domain will work for the inverse as long as I have it restricted, okay? The same thing will be true right here. Works out much the same way. If you're stuck, drop into the discussion. Let's talk about it. All right, enough inverses. I will see you in the next section.